Welcome to the next webinar in our series on the Copernicus Data Space Ecosystem. Thank you all for taking the time to join us today. So before we start, I will just be going through a bit of housekeeping. So interaction with our guest speakers is exclusively through the chat. So please feel free to ask any questions there at any time. There will be a dedicated Q&A session toward the end to address your questions. The questions for our speaker, Mr. Branimir Radun, will need to be answered at a later date because he won't be here for the Q&A. So that's just a note. He won't be answering them live today. For any technical difficulties you might experience, especially with audio or the swap card application, there are some steps you can take. Please make sure your audio device is correctly selected. If your problems persist, try accessing the meeting via a private browser. So this is Control-Shift-N in Chrome or Edge. One final note, the session will be recorded and will be available on Swapcard in the next day or so. So now, without further ado, I give the floor to Valentin Lupetti, who is Information and Communication Officer at the Directorate General for Defense Industry and Space at the European Commission. Valentin, the floor is yours.
Thank you, Evan. Hello, everybody. Thank you for joining us today for this fourth webinar. I'm right, first webinar on the CDSE. So today, it's in this format, we will try to move from theory to practice with two concrete application of the real world, as mentioned in the title. So we'll hear from Branimir Radun from OIKON. So we'll see how the data space ecosystem help them on the field when it comes to environment protection. And then we'll give the floor to Bert de Roo from VITO. And here we will hear from high-resolution satellite imagery project and how it helps to monitor land and biodiversity. So I will give the floor to Branimir first to hear about OIKON.
Branimir Radun here representing OIKON Institute of Applied Ecology, environmental consultancy from Zagreb, Croatia. Just a couple of slides about the company, so just that you get an idea about why we have the need for easier downstream EO data processing and why the Copernicus Data Space Ecosystem is proving to be more and more useful, and I think will be crucial. OIKON is a environmental consultancy with 27 years of experience, and we work on the market. We are also a scientific research institute and have been in the field of downstream EO as part of our work since the very beginning. So we have passed through all different stages and know how things were before and how things are now. Okay, just a short overview about our services. These are very different services, all related to environment and nature protection, and the Earth observation downstream EO is a crucial part of many of those services. So basically, the applications are possible everywhere. So how does it impact the market? Since we are a entity working on the market, it's important for us that we see actually financial benefit from using Copernicus Data Space Ecosystem, and this is something that we actually do see in various applications in various ecosystems. For example, one of our bigger and recent projects was mapping of marine habitats of the Croatian side of the Adriatic. This was a very, very big project. Around 27,000 square kilometers were mapped, and a large part of that was mapped using Earth observation data. Specifically, the biggest load was on Sentinel-2 data, as I guess the situation is around the world, actually, at this point. So basically, what was needed, we needed to download a lot of data. We needed to have storage capabilities, processing capabilities. We needed to do everything locally, indices calculation, time series creation, which is important for vegetation analysis, for vegetation season analysis. We needed to do R&D, which is basically machine learning classification, convolutional neural network classification, and so on. It all needed to be done locally after the images were downloaded, and basically it takes time to do that. Data needed to be fused with, so Sentinel-2 data needed to be fused with high-resolution aerial survey data. And there are a couple of problems here, which you are probably, as users, familiar with. The rolling archive, which was there when the data load got too big, I guess. When you needed longer access, you needed to order images which were older than 2 years. Since we were doing time series for 3 or 4 years, this was very important for us. You need local storage, even for R&D. You need local processing capabilities, and you need to access multiple Earth observation data sources and repositories. And what's different now is that we can do it. Many of those steps we can do using Copernicus Data Space Ecosystem. So basically, statistical access, eval-script access, APIs make development easier and faster and cheaper. In our case, for example, custom atmospheric correction, you are all familiar with Cent2Core, and this is a perfect algorithm for vast areas in Europe. But sometimes you need a different kind of atmospheric correction for coastal areas, and this enabled us to do that. We could create time series, analyze them, which is important to differentiate different habitat types. Our method development and project implementation would have been faster and more streamlined, and that would, of course, impact the overall profitability, which is always an important thing. Thank you. This is not the case just for marine habitats. Terrestrial habitats are also something where the approach is pretty similar, and the issues are the same. You need to download, process locally, and do trial and error, and hope for the best. CDSE helps us in that. We can do cloud-based method development, custom script development. Bring your own data API, especially, could be useful with high-resolution UAV data. Fusion with in situ data. You always have projects always include junior experts who are still learning, coming into the field, and basically QGIS plugins and stuff like that, which was developed with the CDSE, makes local processing easier, faster results, and makes the access to Earth observation data, Copernicus Earth observation data, easier and faster. In the application of precise agriculture, this is just an example of a project where you need to ask yourself a question: do we really need the images? This is an example of mapping the agricultural area, all agricultural lands in Croatia for 16 most dominant crop types. This was a huge amount of data. So basically, we needed to take into account crop rotation and permanent crops and so on. The period of analysis was 5 years, I think. And it wasn't just multispectral data, it was SAR data, so integration of Sentinel-1 and Sentinel-2 data. To do what? To stack the images, to apply your machine learning algorithm, and to classify the field. And the output is not, we didn't need actual images, we needed the data that was in the images. And this is, in most cases, true, and in most cases this is what we really need. And the output was, it's not a map, it's actually data that provides us with information and knowledge, and the output is always used to for strategic planning, to derive some knowledge that will guide us into right direction. Forest ecosystem research is this is probably a familiar example to a lot of users, since forest ecosystems and research of forest ecosystems is something where, at this point, the Earth observation data is more applicable, most applied. So you have a problem. You have a large infrastructure project being planned in the area of the largest pendiculate oak basin in Europe, and it's very valuable habitat, both biologically, from the biodiversity point of view, but also commercially. And you need to see how this infrastructure project will impact those stands, those huge forest stands. what you need, you don't need images. In this case, this is MODIS data. You don't need images, you need the data behind those images. You need time series that show you what is going on at this moment with the vegetation, what is the health status of that ecosystem, what is the baseline through which you will measure all future impacts. So basically, you need to see what is the productivity of the ecosystem, what is the amount of stored carbon, what is the seasonality parameters, so that you can determine if the ecosystem is healthy or not. In this case, the baseline was that the ecosystem was not that healthy, actually, and the reason for that, on the right side, you can see the seasonality and seasonal changes. And the reason for that was a bug that probably anybody from Central Europe is familiar with at this point. This is a bug which is, in real life, it's below 1 millimeter in size. It came from southeast and spread throughout Central Europe, infesting oak forests and basically doing a lot of damage on the oak forests. And basically what we, studying the data, we saw something was wrong. We knew that this pest was coming, and we could measure its effects and its impact. Okay, so there were weeks, if not a month or more, behind this research 4 years ago. This is the recreation that I did basically in 2 minutes using Copernicus Data Space Ecosystem and its viewer, where you can determine your own AOI, delineate it, and basically in 2 minutes you can get the information about the vegetation dynamics, the dynamics of the vegetation season. It isn't exactly phenology, but it's something that it's very close to phenology. And this is it. 2 clicks. Already here you can see the shift in the vegetation dynamics, and you can see the impact of this pest. Okay, so to summarize what I said, and this is from the forestry perspective, but this is also applicable into all areas of application in the environment and nature protection sector. Images are secondary. What we need is the insight and the data. This data, I said this like 5 times already, but this is important. We need the data to derive knowledge and to guide us into the right direction. And it's always, you can see this image where using the data from Earth observation satellites, from sensors, you can use data gathered from space to monitor how a bug which is smaller than 1 millimeter actually spreads. And I always like this example because it's always fascinating to me to view something from space and see something so small. And what is the knowledge here? The knowledge here is, okay, so it's spread from the east, from southeast. And how does it spread through Europe? You can notice the hotspots of infestation are around highways. So it spreads through trucks that carry logs. And when the truck driver stops to get some coffee, the bugs fly out of the logs and infest local oak forests. So this is the kind of knowledge that guides us into the direction of how to act upon it, how to stop further spread. In this case, this is very hard. Also about gaining knowledge using Earth observation data, not the images, but the data that it brings, is monitoring the phenology of vegetation, which is one of the most important tools to monitor the effects of global climate change. In this case, it is monitoring phenology of beech forests in the Dinaric Alps. You can move forward. When it comes to, and this is just to sum it up in the example of invasive plant species monitoring. So here, in this case, you have a problem that you need to detect one type of vegetation that infests other types of vegetation. Everything has a similar vegetation season, but this one is that comes is alien, is problematic to the local ecosystem that has developed here throughout the years, throughout the centuries. Copernicus data, the ecosystem gives us the ability to basically develop and test the approach and methodology to do this faster. There is a lot of trial and error here. You need to, it's really tricky to do that using Earth observation data, but it's possible. And it takes a lot of time, a lot of trial and error. And to be commercially successful, you need to make your errors as cheap as possible. And this is where CDSE helps us. Through its custom script development, quick visualization of results, and so on. So this is the biggest positive impact. In conclusion, again, repeated designing capabilities of CDSE make innovation and growth in downstream EO possible and easier to achieve. It's always important to make it easy to newcomers to take up something, to start in the field, to make it as cheap and as approachable to them, because it basically builds upon the knowledge of the community, and this is important. Copernicus data has never been more accessible. This is also a fact, an important one. Those of you who remember it from 2016-17 will know. This CDSE is already a very important tool and will be more important tool in the future as it develops. And just to leave you, this is a capture of a heart-shaped island in Croatia, Galesnjak. It's very popular for weddings. And this is the NDVI profile of vegetational season dynamics of that island, which basically is here to remind us that we are living on a living planet which is breathing, and we need to get as much as info about it as possible to help us protect it. And this is it. Thank you.
Thank you very much, Branimir. It was very interesting to see these positive impacts that the CDSE is having on downstream EO, the availability of data very quickly for immediate insights. It's always nice to see these concrete examples of how users are working with it. Our next speaker, Bert.
Yes. Hello, everyone. Thank you for inviting me for this webinar. I will talk about crop types and cropping pattern products that we are producing for the HRL Vegetated Land Cover Characteristics, and we use it we do it using OpenAO on CDSE. So it's actually a quite big project that's under the Copernicus Land Monitoring Services that these things are produced. So we're talking about actually the new high resolution layers for vegetated land cover characteristics, so in short VLCC, and it consists actually of an harmonized forest, grassland, and crop products. So the forest and grasslands were already in the old HRL layers, but the crop products are new to this project, and I will be talking mostly about the HRL crop type and cropping patterns, because those have been produced on CDSE with OpenAO. So a bit more on the HRL forest and grassland. So they are aimed to have a time series that continue over time, and as such further densificate the well-established HRL layers that are already present. Those products are actually status layers with a spatial layer of spatial resolution of about 10 meters, and we also produce change layers for forest and grasslands at a spatial resolution of 20 meters. And there are actually yearly updates of these layers starting from 2017 for crop type products and cropping pattern products, currently extending into 2021 and foreseen to also extend into 2023. It's a pan-European coverage, this product, so it actually covers EA 38, so and also the including overseas areas. It's, as I said, quite a big consortium working on this project, so it's really the purpose to produce maps that can be used later on in downstream OpenAO application or other applications. And we're working on this on the CD infrastructure on WKO. And GAF is the German lead that's mainly doing the base vegetation layers and the forest products, while GeoVil is also German-based, works on the grassland mowing and also the production and dissemination system, while VITO, where I'm part of, is mainly interested in the crop type and cropping patterns. And we have some subcontractors working on validation and dissemination of the products. So as said, at this moment, we're in the processing of the reference years 2017 till 2021. And actually, good news, very soon this product will be available at the end of October. And as said, we also in the process of producing 2022 and 2023, and those will be, the publication will be expected at the second half of 2025. If you're interested in these products, we also have some webinars dedicated to every product in specific every time at the end of the month. So we have one at the end of October, one at the end of November, and one at the end of December. So if you're interested in these products, you can have a look and try to use them in your applications or whatever. So now a bit more on the crop, because the crop types are really produced on CDSE together with the input data from CDSE. So we actually, for our crop methodology, we use 3 time series that are available on CDSE. One is the Sentinel-1 time series and Sentinel-2 time series. As also discussed in previous webinar, those are actually quite often used. And we also then use the digital elevation model, Copernicus 30 meter in our case, to have some information about the altitude and slope. So these data is available on CDSE. And then we also upload some extra data to OpenAO to also work with some Agera 5 data, which was at that point not yet available on CDSE. So all this data have been used in an MLP deep learning program to have then this data model applied on our input time series, which is also running on CDSE. And as such, we create our crop types maps, which then are actually in a later steps locally, in this case, post-process to have some interannual consistency checks, and also to do some spatial cleaning to eventually obtain our final crop type maps and crop type confidence layer maps. So this is for our crop type product. And for our cropping pattern products, it's a bit more elaborated because we have different models that are running on CDSE or locally, and we're also using the time series from CDSE, which then are fed into our model. So in the first part, actually, we use the Sentinel-2 time series from CDSE, which is then applied a parcel delineation model also on CDSE to actually obtain parcels for the pan-European area, which is then fused into our cropping type to have cropping patterns parcels. And this data is then again re-uploaded on CDSE to have some aggregated time series over these parcels based on Sentinel-2 and Sentinel-1. And those are then combined to have our harvest detection and also on our emergent detection to create our cropping pattern products, as we can see there on the right side. So main crops, bare soil, all kinds of typical cropping patterns that you would expect. So how does this look on OpenAO? So as said, we're using OpenAO on CDSE to analyze, process all our data to produce our pan-European cropping type and cropping pattern maps. So here I just make like a small overview of how our workflow looks then on OpenAO itself. So actually we first load in CDSE available datasets. So in this case, those are the collection Sentinel level 2A, Sentinel-1 GRD collection, and then the digital elevation model. So that's the Copernicus 30 model. These are then processed. So in the first case for Sentinel-2, we apply a scene classification mask and resample it to a resolution of 10 meter and projection of 30-35. This is all done on CDSE because it automatically detects how to do these things without users really need to take care of some nitty-gritty stuff around it. The same actually for the Sentinel-1 that then is applied a SAR backscattering calculation, and then again resampled spatial to also the 10-meter resolution and the LAIA or APS-G 3035, which is the pan-European standard projection. And for the same for the Copernicus 30 layer, where we then actually drop our time dimension, because every data cube has like X, Y, and time dimension. But in any case, this digital elevation model does not take into account the time, because for every year the same. So what are the next steps? Well, we filter again the bands that we are using, that we need to use for our model. And also, yeah, this is only for them, so it doesn't really matter. And then we try to aggregate the temporal period. So we only use, instead of the whole time series, we try to aggregate everything into 10 daily steps. So that's why it's also done automatically on CDSE. And then in the later step, it's just respatial and combining every data cube. So the data cube from Sentinel-2, the data cube from Sentinel-1, and the one from the digital elevation model. We merge them all together. And then here in this step, we apply our model to this data cube to obtain our geotiffs that describe or that contain the results of our data model. Now I will talk about more about how we run a job on OpenAO and what's actually the benefits of running these jobs on OpenAO instead of doing everything on your own way. Well, one of the main benefits that we see is that it's an easy access for all data layers in a unified way. So this is a Python example of how we access the data. And as you can see, it does not really depend on where the data is sitting, on which collection it is. It's just the same format, how to load a collection and how to create a data cube that contains all this data at once without needing to know, okay, this is via this API, this is via that API, I need to download the data, then merge it somehow that it's feasible to put everything in one data cube. In this case, it's all actually quite uniform to do it in one way. Another major benefit of using OpenAO on CDSE to process your data is we do not need to take into account splitting of subtiles. This is for us a big advantage. For example, we work with 20 by 20 kilometer tiles for the pan-European production, but actually those tiles, if you want to have a complete time series, it's way too big, way too heavy to really handle in memory. So OpenAO also takes care of these things to split these tiles in subtiles to really have an optimized parallel processing. Even if we have like a model that takes into account the surrounding, it's also possible in OpenAO to take that into account, and then it's really easy to optimize your parallel processing. OpenAO does it for you. So other benefits that we saw in running jobs of OpenAO is actually all the metadata that is being kept and is available for you to investigate. For example, it keeps track of the software version used. Also, all input data that has been used is keeping track of. So if you find something weird, it's very easy to check all the files that have been used and maybe there's something's wrong. So that's easy to see. And also, we keep all the processing graphs. So actually, this is a kind of a user-friendly visualization of the graphs. But with those kind of things, you can really redo exactly the same processing that has been done. So it's really easy to reproduce everything you have done. And also automatically there is some metadata stored as a stack item. So you can really use that as a stack item to keep track of all the metadata that is available and that has been used. So that was for one job. Now we run a lot of jobs. So as said, we use 20 kilometer tiles, but those 20 kilometer tiles we made ourselves. And then we have like actually a large CSV file that uses OpenAO Job Manager as an, so the OpenAO Job Manager uses this file to track and monitor all the cropping type products or cropping pattern products that we need to produce. So it's really a lot of entries. So we have more than 80,000 20-kilometer tiles that needs to be processed for the 2017 till 2021 series. And we're currently processing 20 jobs at the moment. Standard on CDSE, OpenAO on CDSE is 2, but this can be changed by account. So that's nothing to worry about. So this is actually what you then see in your follow-up. You can really follow up when did my job start, how much memory did it use, how much CPU, what's the duration of my job, and also on which backend, in our case, in this case, and on CDSE has run, and also a job ID. So if something goes wrong with the job, you can try to find out and help for on OpenAO what went wrong. So how does it look in progress? Actually, you launch your job, and the OpenAO Job Manager finds in your file which jobs have not been started. So it actually started in this case, in this example, 3 jobs. So because there are 3 jobs not started, he will launch them on the backend, so CreoDias or on CDSE. And then he follows automatically up every 60 seconds, every 10 seconds. It depends on what you want, how far what the status is of the job you are currently viewing. So in our case, in this case running 2 times running and 1 time just created. And I have just a small slide on also the cost on CDSE, because if you want to run something on OpenAO on CDSE, there are some credits that are related to it to process there. And it's actually quite easily followed, because it's just per job. You can list how much credits you have used to launch this job. So it's actually, this is kind of a summary what you see when having launched a batch job. So again, here you can see your ID when it was submitted. Here also the same information about CPU usage and other things. And here you have then the amount of credits that has been consumed to produce your product or your tile. Just a note on this one, this 2024 is not in production, so it's just a generated example. Yeah. So that's it. Thank you for your time and
Thank you very much, Bert. Very interesting indeed. So it's time for the Q&A. Looking through the questions, I believe that most of the questions were addressed in the chat, or are being addressed right now, as we speak. I don't think I will read them out. I did have one question for you, though, Bert. You talked about a lot of benefits in using OpenAO. CDSE for the development of your product. I was wondering if you can talk maybe a little more about how it's impacted the project as a whole. For example, project timelines, decision-making in the progress, versus doing your processing workflows, for example, locally.
Yeah, I think in our case, we actually started already on CDSE for the start of the project. But what I see from other projects, so just not in one project, but relating different project, I see it's much more easy to really start a workflow and then just check what's coming out without taking too much into account all the like I said, the collections, that they are all aligned, that all the collections are available. That's something that's automatically done on OpenAO, so that takes one burden of how you would develop and how you would look into these things. Yeah.
Yeah, so it
kind of answers your question.
Yeah, no, it does. I know that this project you maybe have been working on OpenAO from the beginning, but from the past projects, from other things that you've seen, it's interesting to always see the impact for these users who are developing these things. So aside from that, I don't see other questions that weren't addressed. I did see one.
Sorry, Evan. There was a question in the chat about possible recent data from June, July.
Yes, I believe that was addressed.
Regarding our project, or
no, this is a general. There were more general questions about the CDSE.
Okay.
But I think maybe that was addressed, but maybe if that wasn't, it's from the same user that asked about how is the CDSE different from Google Earth Engine. Andras is here. Maybe he can address this directly.
Yes, well, it's a big topic because both are big platforms, big infrastructures. The first thing we like to say is that Copernicus Data Space Ecosystem is a public infrastructure. It's owned by a public institution. So it's a non-profit system. It also has a service level agreement, which means it's definitely going to be with us for the next 6 years, but we're actually already negotiating for the next 10 years. So a lot of the risks associated with a commercial platform are not there. Also, the data is first made available on Copernicus Data Space Ecosystem. So everybody who's sharing Sentinel data is essentially getting it from us, which means that you might have a bit of an edge if you need the data urgently. CDSE also has a stronger focus on visualization. So a lot of the products you generate, you can also share in Copernicus browser with this very intuitive, easy to use platform. And we have the fully open source OpenEO API family, which means that your processing pipeline can be followed through end to end. It's completely shareable and findable, which is also, I think, one of the things you don't get with Google Earth Engine. Well, this is in a nutshell. Some of the data products also, so Sentinel-2 quarterly cloudless mosaics, Sentinel-1 mosaics, CLMS data are not available, I think, on Google Earth Engine, but they are available on our side. So this is just one of the few reasons.
Yeah, so it's a big answer. It's a big question, right? I see some other questions. Maybe Jeroen, you're kind of answering these in the chat, but there's an interesting question here about the near real-time monitoring of forest loss in tropical regions. And Valentin, I think this ties into some policy as well. Could maybe be a bigger discussion about the EUDR. So I don't know if Jeroen, you'd like to address this.
Yeah, sure. I'm only involved sideways, but there is a project that is in the implementation phase. It's a Copernicus operational service for land cover and forest, tropical forest monitoring. And they will provide maps, but will also in the first phase, it will be more like a static map. But then one of the follow-up things is actual near real-time production of various indicators, so that you do not only have static land cover, but also like what is going on in real time. So that is going to be very interesting for that, especially because it's an operational Copernicus service. So not just another like project that does a one-time thing, but really a long-term activity that is designed to address this use case, and also to ties in very much with policy and legislation from the EU side. So it's really a tool for that.
Does anyone have any additional comments?
Maybe the one whether data can be connected to other platforms through APIs. The best way that we use is via Stack APIs, actually. So what we try to do, at least in OpenEO, is publishing data with Stack metadata, and to really fulfill those FAIR principles about data access. And then actually any other platform that supports reading from Stack can load the data. So we see that very much as the interconnection. Of course, other platforms can also talk to our APIs, can talk to OGC APIs, but Stack is definitely also a very interesting tool for exactly that.
And we had another question pop up from Fabian Schroer. When will the first S2C data be published? So the Sentinel-2C data. And I'm assuming this is the CDSE. So.
Yes, I think it's best if I answer. I'm already typing the answer in. So actually the approach with Sentinel-2C is that it's not going to be an additional satellite in the selection, but Sentinel-2A will be retired and kept in orbit as an in-orbit backup. And so Sentinel-2 data on the long run will still be provided by 2 satellites. The first couple of first light images, which you can already find on social media, are expected to be in the platform hopefully by the end of or mid-November. We don't have an exact date on them, but operational Sentinel-2C imagery will be integrated into the platform at the same time Sentinel-2A data will be retired. And that has to happen after the full commissioning phase of Sentinel-2C, which is going to take at least a couple of months.
Okay, so that puts us, you think, in terms of the timeline, that puts us at the beginning of next year, something like that?
Probably, yes. But I think the main message here is that there's not going to be a major change in data frequency or revisit time.
Okay. Okay. All right. So I don't see other questions. Does anyone in the audience have other questions? Maybe we'll leave a moment for you to finish typing them if you are doing so. Otherwise, I think that we'll go ahead and I'll go ahead and give the floor to Valentin, who will close the meeting.
Yeah, okay. Thank you, Ivan, and thank you very much for participating today. Thank you very much to our guest speakers. I think it's always very, very important for us to broaden the spectrum of possibilities brought by the CDSE, and I hope that it will be an incentive for all of our auditors to develop their own project, their own application in their respective fields. So voilà. See you next time for our next monthly webinar.
And thank you very much, everyone.
Bye.
Bye.
Thank you.